Hey, I'm Eno,
My name's Jason.
and this is Go Build It.
So today we were going to finish up our series on deploying the Mile High Gophers website, and basically all we need to do is install Docker on the virtual machine that we have for the website, and then create a systemd unit file, which we already have created down here, and then just enable it and do a TF apply, and that should deploy the website.
Yep.
So a lot of this stuff we kind of did a little bit up front, but we wanted to go through and kind of explain most of it. These unit files are kind of a little bit tricky to get right. Like you sometimes spend 30, 40 minutes just like doing TF apply, trying to make sure it applied correctly, and then you'll have a YAML error where you miss a space here, and then that destroys the cloud config. So
Yeah.
we figured we'd save you guys from all that and just walk through it.
So we got the virtual machine created last episode. I think we've got
I think it's 2 episodes.
two episodes ago.
Yeah.
We have our binary now in a Docker container. It's nice and neat.
Let's go ahead and show that. I don't think the tail end of last episode, I don't think we actually showed it. So if you go to hub.docker.com/r, Mile High Gophers website, that's where our image is stored, and then there's just one version of it that we did 2 weeks ago.
Cool.
It's 81 megs. That's it.
Cool. So the next step now is to make it so that we can start the Docker container, and rather than just have Docker, just say Docker start. We'll manage it with systemd, so if it goes down, it will come right back up. Systemd will do all that hard work for us.
Cool. So we're just going to go under cloud config here, and we only have one cloud config. And the first thing we have to do is install Docker. So if I go back over here, I have all the commands. We just got these commands off the Docker documentation.
Yep.
For how to install the community edition. So I just paste those in there. And anything under this run command key will be just commands that get ran on as a root on the first start. So we don't need that, but these guys here we do need.
And so this is just taken verbatim straight from the Docker website about how to install Docker on Ubuntu.
So we can do a TF apply now just to show the Dockers there, but it's not really that interesting.
Yeah.
So let's go ahead and show the unit file here. So we don't need any of this anymore.
So for those who aren't familiar with systemd, it seems like it's becoming the standard way to manage processes in Linux distributions.
Yeah, it was a few years ago now that Debian adopted it, and once Debian adopted it, Canonical said that they'll adopt it for Ubuntu, and CoreOS has been using it for a long time. Pretty much all distros are kind of moving towards it. It's a very contentious transition, but seems to be the way things are going.
So there are all sorts of other tools out there, I think, for managing processes, but it seems like this is the preferred usage. Not even using, I think Docker itself has some features that support process management, but from what I understand, systemd is the way the cool kids do it.
So we have this section called write files. So that's just a cloud config section. Let's go ahead and just pull that over here. So anything under here will get written out to the file system. So we're going to write out a file called systemd system website.service. So all your unit files typically have a .service suffix extension. Set the owner to root, set its permissions to read write for root. And then here's the content. So this is an INI file. All unit files and target files and sockets and everything are INI files. So you have a section unit, and that just kind of describes the unit file. Requires will basically put a dependency on this unit file on the Docker unit file. So if Docker goes down, it'll take down our process as well. So sometimes you might want that. Sometimes you might want there's like a wants declaration that we're reading about. So that's a little bit of a soft requirement. So if Docker goes down, your process won't go down. But since we're kind of dependent on Docker, we just figured requires is appropriate here.
And there's just this little break. Let's show the documentation here. There's all sorts of details about these unit files.
Yeah, if you, let's see, let's go back here. If you just Google for like unit files, you'll see the man page for systemd unit, and that just has all the information you'd ever want. And usually what I do is just scroll down to here, and this describes everything that you can put under that unit section. And then down here, there's like a service section, so that's install. And then they have examples as well. I think there's a service section here. Might get a different man page.
A ton of information in here, so it's clear that systemd is super powerful. We're kind of just keeping it simple in that we want it to come up, we want our particular service to come up after Docker, and we've got a couple details about how things can be started and stopped. But
yeah, I think the service section is probably documented somewhere else, but if you just Google for it, these man pages have a lot of information. So we're using requires just because we have a dependency on Docker, and then there's before and after. We use after, so we want to be started after Docker daemon has been started. That's kind of like the ordering in which we want to start up. And then maybe we can just discuss this install section down here. Most unit files use wanted by multi-user.target. You can see in the examples down here they use that as well. Pretty much every unit file I've ever seen uses this multi-user target in order to wire everything up. And then the meat of the unit file is the service section. So we have these 3 commands that will be ran before our actual process will be ran. And you can have as many as you want. If you put a hyphen in front of the command, that means if the command exits with a non-zero status code, it'll just ignore it and continue on. Whereas if this third command exits with a status code, it'll actually fail the unit file.
so you're setting this up such that when we do subsequent deploys of this, we'll be able to stop the process, get rid of the container, and then go pull the new image, and then here's the new start.
Yeah, most of this I pulled from CoreOS's documentation. I use CoreOS personally, and this is just kind of the way that they documented how to
turn the lights
Docker.
off, clean everything up, and then go get the new stuff and start it again.
So the exec start here is just you calling out to Docker saying I want to run this container Gopher's website latest, and give it a name so that we can then kill and remove and stop it. And then there's some environment variables here and some port forwarding. So if you're not familiar with Docker, -e just sets an environment variable inside the container. So we're saying inside the container, the process should bind to port 80 on any interface, and the time zone is America Denver. One thing that I noticed in some testing over the past few weeks is that Docker uses the Zulu UTC 0 offset time zone. So all of our when we ran the process locally on our Mac, it got the right time zone and displayed correctly. But then if you ran it inside Docker, it would be like the days would be wrong because it's 5 or 6 hours difference.
I think like as a general convention, it's really good to have your servers running in UTC and do all time zone stuff on the client. But because this is a Denver specific thing, I feel like we can break that rule a little bit.
And I was reading a little bit on the Go standard library. Like you can receive like a locale from the user when they hit the website, and then kind of adjust the timestamps for their locale. So if we wanted to add that feature, we could later. But yeah, like you're saying, this is like Denver centric. So.
Yeah, so we can break that rule a little bit here.
Yeah, and then this -p just means port 80 inside the container exposes port 80 outside the container on the host VM. So that's pretty much it for how we run it. And then when we stop it, it just Docker stop website.
Yep.
And then this is a very important declaration here is restart always. If you don't put that, when your process crashes for whatever reason, systemd won't bring it back up.
Yeah.
So you want to always have systemd bringing your process back up if it crashes. So not always. There's different values you can put here, but for our purposes, we pretty much always want it to come back up.
Yep.
User root just runs it as roots. This is a timeout seconds, and then kill mode done. So that's pretty much it for our unit file.
Yeah, so the key thing really is line 39 here.
Yeah.
I mean, that's really what we want systemd for. So for whatever reason our process dies, we want it to be right back up and continuing serving requests.
Yeah. Cool. So
that's all good.
Do you want to capitalize website up here? No.
Yeah, let's do it.
Alright. So that's the unit file. Let's go back to our thing here. So we did that. And then I was actually unfamiliar with enabling and starting unit files. Since I use CoreOS, I think they just do that for you behind the scenes. So we noticed, even though we put the unit file in the appropriate location for systemd to know about it, systemd wasn't picking up the unit file. So apparently you have to say systemctl enable and then give it the unit file, and that'll actually enable it. And then the first time you enable it, you have to start it.
Yeah, so this is the kind of stuff you would do if you were just a sysadmin and working around on a command line that you'd manually call enable and you'd manually start. But we're just going to do that as part of run command when we create this virtual machine. All right, so that should do it. We've got creating the machine, we've got creating or installing Docker, and we've got this unit file stuff that's going to be consuming this website.service.
Yep.
So we're getting pretty close to the end of this series now.
Yeah.
Started from 0, and now we're going to have like a fairly robust deployment of our little bitty website.
So I don't know how that got there. Do you want to do a TF apply?
Yeah.
So we tore down the old VM before we started recording here, so this is just not responding. But we left in place the floating IP address and all the DNS configuration, so we wouldn't have to like wait for all that to
go configure some stuff.
Yeah.
So on.
So just do a TF apply. This is all the cloud config that we're providing it. This usually takes like 40 seconds at most.
All right. So for the sake of our viewers, maybe we'll stop the recording for a moment.
I mean, it's
Watch the
DigitalOcean.
stuff.
Usually it takes only like
Right.
a few seconds here. DigitalOcean is really good about startup time for their VMs. So let's go over here. I kind of want to do this curl thing. So this is just a curl that I have for testing the website to see if it's up. So if it's 000, that means it's down. So we'll see how long it takes for it to come up. And then maybe we can try SSH AMD here.
Yeah.
So this will probably freak out because, no host violation. Alright, so we're able to get into the machine, but it hasn't come up yet. If we do...
Oh, there's the 200s.
Oh, there it is.
So what was that? Was I don't know, maybe a minute?
Yeah.
And there was like downloading Docker. So if we would do a subsequent deploy, I'd imagine it'd be a little faster.
Yeah. Yeah, it's one thing when you do the Docker pull in your unit file, like if you don't have a local cache, or if you rebuild your image and you invalidate that cache, like it has to pull down everything.
Yep.
And we were only about 89 megs, I think it was,
Yeah.
so it's not terribly big binary, but
Yeah.
yeah, you want to keep your image file small and like cache as much as possible.
Yep.
Try not to invalidate that cache. So it looks like, do we have a panic here? Looks like we did.
Interesting.
Servermux HTTP. Looks like it's up.
We're getting 200s though.
Yeah.
Oh, there it is.
I wonder what happened there. Maybe it brought it back up.
Huh.
Or maybe there's just a log here. Instead of doing follow, let's do -u. That'll give us the full thing. So it looks like it was freaking out about something. Invalid memory address. So we got some bugs. Maybe it's the curl thing that I have hitting it, or it could have been when it was just starting up. There was some issue.
Possibly. But
It's a lot of template stuff now.
yeah, it is definitely doable to make a Go binary serve HTML, but it seems to me that if you compare that to how other frameworks, languages do it, you really don't want to be serving HTML out of your Go binary if you can avoid it. I feel like serving JSON or doing kind of lower level stuff is just so much easier
Yeah.
than doing server-side rendering.
So one thing I kind of want to demonstrate is, so we have this curl loop just hitting the website, and if we do psaux, actually we can do docker kill, yeah, docker stop website.
So if for some reason our container crashed or whatever,
You can see there's only like a few requests where we had downtime, and then systemd brought it back up almost immediately.
cool.
Is there anything else you wanted to demonstrate?
You'd show that the Docker dies, the website will
Oh,
die
yeah.
as well.
Yeah, so psaux grep docker d. So we can just kill Docker here. So even if Docker goes down, systemd should bring it back up.
And there it is, the 200s are back. So, a fairly robust deployment. I mean,
More robust than like running a random binary that we SCP'd up to a VM
using
tmux.
Using tmux, yeah, that's not going to last long.
Yeah.
So, anyway, I think that's it.
Yeah, I think that's all I wanted to really cover today. This week we're going to be at GopherCon, so if any of you guys are there and you see us there, give us a shout out.
We got some stickers.
Yeah, we
Little
got some stickers too.
So,
Yeah.
let's see, let's just review for those who might want to look at home. We're going to push this deployment up. Let's see here. Where are we keeping this stuff? Oh, I can't remember if we're putting it in Go Build It or Mile High Gophers. We have this org up on GitHub, so a lot of this source code that we've been looking at, there's the deployment, there's the website,
Yeah.
it'll be here.
Yeah, this is all the stuff we've been working on. We also have an org for Go Build It. And this is where we're working on kind of, stuff related to the Go Build It series. And we got a new logo too.
Yeah, there it is. All right, well, so
Yeah.
that's it. End of the first series, I guess.
Yeah. Cool.
Cool.
See you guys.
See you next
Yep.
time.